Welcome everyone. In today's digital world, almost everything we do involves information. We take photos, write assignments, send emails, download notes, and store files online. All these activities involve digital information. Digital information management is about how we create, organize, store, protect, and use digital information properly. Without good management, information can easily be lost, damaged, or misused. For example, imagine losing your assignment file just one day before submission because it was not saved properly. Or imagine someone accessing your personal documents because they were not protected. In this lecture, we will learn what digital information is, what digital information management means, and why it is important for students, professionals, and organizations. By the end of this session, you will understand how to manage your digital files more effectively in your daily academic and personal life. In the digital era, information is no longer limited to books or printed documents. Most information today is created, stored, shared, and accessed in digital form. Because of this, digital information science and digital information management are closely connected. Both focus on how information is handled in a digital environment, but they play different roles. Digital information science provides the theoretical foundation. It focuses on principles, theories, and technologies related to how digital information is created, organized, retrieved, and used. This includes areas such as information systems, data structures, user behavior, and digital technologies. Digital information management, on the other hand, focuses on practical application. It applies the knowledge from digital information science to real-world situations. This includes managing digital files, systems, databases, security, and information workflows. In simple terms, digital information science explains what should be done and why, while digital information management shows how it is done in practice. Together, they work seamlessly. Digital information science drives innovation and understanding, while digital information management ensures digital systems are effective, secure, and user-centered. To understand how digital information science and digital information management are connected, let us look at the role of each field with simple examples. First, digital information science focuses on the theoretical aspects of digital information. It explores the nature of digital information, how it is structured, and how it behaves in digital systems. For example, when you search for articles using Google or an online database, digital information science explains how the search system understands keywords, ranks results, and retrieves relevant information. Digital information science also develops tools, technologies, and algorithms to organize and retrieve digital data effectively. An example is how a library database uses metadata such as title, author, and subject to help users find books and articles quickly. In addition, this field studies user behavior in digital environments. For example, it examines how students search differently on mobile phones compared to laptops, or why users prefer simple search boxes instead of advanced search options. Next, digital information management applies these ideas in real-world situations. It focuses on how digital information is handled in daily practice. For example, when a university stores student records in a secure system, manages access permissions, and controls who can view or edit the data, this is digital information management in action. Another example is managing digital lecture notes, saving them in structured folders, backing them up in cloud storage, and ensuring students can access the correct version. Digital information management also ensures legal, organizational, and technical compliance. For instance, protecting personal data, following data protection policies, and preserving important digital records for future use. In summary, digital information science explains how digital information systems work, while digital information management shows how these systems are used and controlled in practice. Together, they ensure digital information is organized, secure, accessible, and user-friendly. In this slide, we compare digital information science and digital information management to clearly understand how they differ and how they complement each other. First, let us look at the definition. Digital information science is the theoretical study of digital information. It focuses on understanding the nature, structure, and behavior of digital information, and how it can be used effectively. Digital information management, on the other hand, is the practical application of these ideas. It focuses on managing digital information so that it is accessible, secure, and usable in real situations. Next is the focus. Digital information science concentrates on research and development, such as creating theories, models, and technologies for handling digital information. For example, researchers may study how search engines rank results. Digital information management focuses on implementation and maintenance. For example, setting up systems to store files, manage access, and preserve digital records over time. Now, let us consider the objective. The objective of digital information science is to understand and innovate how digital information is created, organized, and retrieved. The objective of digital information management is to ensure digital information is efficiently managed, secure, and accessible to meet user or organizational needs. Looking at key activities, digital information science involves developing metadata standards, designing retrieval algorithms, and studying how users interact with digital systems. Digital information management applies these standards in practice, for example, using metadata to organize files, ensuring secure storage, and preserving digital content. In terms of nature, digital information science is conceptual, research-oriented, and theoretical. Digital information management is operational, application-oriented, and practical. For tools and technologies, digital information science uses technologies such as semantic web tools, artificial intelligence for language processing, and data mining. Digital information management uses systems like content management systems, digital asset management systems, and cloud-based storage. Regarding disciplines involved, digital information science draws from computer science, information theory, and human-computer interaction. Digital information management involves IT infrastructure, library and records management, and data governance. Finally, let us look at an example. Developing an AI-based recommendation engine for a digital library is an example of digital information science. Implementing and managing a digital library system that stores, categorizes, and allows users to retrieve academic resources is an example of digital information management. In conclusion, digital information science creates the knowledge and tools, while digital information management applies them in real-world systems. Together, they ensure digital information is intelligent, organized, secure, and useful. In this section, we will look at the definition and concept of digital information and digital information management, often known as DIM. First, let us understand digital information management, or DIM. Digital information management refers to the comprehensive processes and technologies involved in handling digital data throughout its lifecycle. This includes the creation, collection, organization, storage, retrieval, and disposal of digital data. According to Smith, Brown, and Lee, digital information management aims to ensure that digital information is efficiently managed, accessible, reliable, and secure from the beginning until the end of its lifecycle. In practice, this means managing digital information in a structured and responsible way, rather than storing files randomly or without control. Digital information management may include activities such as creating digital content, organizing files using folders or metadata, storing information in secure systems, retrieving information when needed, sharing or disseminating information, preserving important digital records, and governing how information is used. As highlighted by Johnson, Miller, and Wong, the goal of DIM is to ensure that digital information is accessible, usable, secure, and preserved for future use. Now, let us look at the concept of digital information. Digital information refers to digital data and content that is created, stored, and processed using electronic devices and systems. More broadly, it also refers to the entire process of handling digital data and information throughout its lifecycle. Examples of digital information include documents, images, videos, emails, databases, and online content that we use every day as students. In summary, digital information management provides the framework and practices needed to manage digital information effectively, responsibly, and securely in a digital environment. In the digital age, information is one of the most valuable assets for individuals and organizations. Because so much information is stored digitally, protecting and managing it properly has become very important. One key importance of digital information management is improved data security and compliance. Sensitive information, such as personal records, academic data, or organizational documents, must be protected from unauthorized access and data breaches. Effective digital information management practices help ensure data security by using methods such as encryption, access controls, and regular system audits. For example, only authorized users are allowed to access certain files, and data is protected using passwords or secure systems. Digital information management also supports compliance with legal and regulatory requirements, such as data protection laws and industry standards. This helps organizations avoid legal problems and maintain trust with users. Another important benefit is enhanced accessibility and efficiency. Digital information management enables organizations to store, retrieve, and manage large volumes of data efficiently. By using digital tools and systems, information can be accessed quickly and easily when needed. This improves accessibility, streamlines workflows, and reduces the time and effort required to search for or process information. For example, instead of searching through paper files, users can retrieve information instantly using digital systems. In summary, digital information management is important because it improves data security, ensures legal compliance, enhances accessibility, and increases efficiency in managing digital information. Another important aspect of digital information management, or DIM, is its role in facilitating collaboration and knowledge sharing. DIM systems and tools provide platforms that allow users to share, access, and manage digital content together. This is especially important in remote or hybrid work environments, where team members may be working from different locations. For example, when students collaborate on group assignments using shared documents or cloud platforms, digital information management ensures everyone can access the latest version of the file and work efficiently. Next, long-term preservation and access is a key importance of digital information management. As digital content continues to evolve, it is essential to preserve digital information so it remains usable in the future. DIM practices address challenges such as digital obsolescence, format changes, and data degradation. For instance, older file formats may no longer be supported by new software. Digital information management helps by migrating data to new formats and ensuring important information remains accessible over time. Another major importance of digital information management is support for decision-making and innovation. Effective management of digital information provides a strong foundation for informed decision-making. When organizations have access to accurate, reliable, and timely data, they can analyze trends, plan strategies, and make better decisions. DIM supports data-driven decision-making by ensuring relevant information is organized, trustworthy, and easy to retrieve. In summary, digital information management is important because it supports collaboration, enables long-term access, and provides reliable information for decision-making and innovation in a digital environment. Digital information management follows a life cycle, which means digital information goes through several stages from the beginning until the end of its use. The first stage is creation. This is where digital information is generated or acquired. Examples include creating documents, writing reports, taking digital photos, recording videos, or digitizing printed materials such as books or forms. Next is capture. At this stage, digital information is captured from various sources and formats. This may involve scanning documents, digitizing old records, or extracting data from systems that already produce digital content, such as emails or online forms. The third stage is organization. Here, digital information is organized and classified so it can be easily managed and retrieved later. This involves using metadata, folders, labels, or classification schemes to structure information properly. After that comes storage. Digital information is stored in suitable storage systems such as on-premises servers, external drives, or cloud storage. The choice of storage depends on factors like security, accessibility, and scalability. The next stage is access and retrieval. This stage ensures that users can access digital information when needed. Examples include role-based access controls, search engines, and user-friendly interfaces that allow users to find information quickly and securely. Then comes use. Digital information is used for different purposes such as research, decision-making, learning, or content creation. For students, this includes using digital resources for assignments, projects, and presentations. The next stage is maintenance and preservation. This stage focuses on maintaining the integrity, authenticity, and usability of digital information. Activities include preserving files, preventing data loss, and addressing issues like outdated file formats. After that is disposition. This involves disposing of digital information in a secure and compliant way when it is no longer needed. This may include deletion, archiving, or transferring information to long-term preservation systems. The final stages are monitoring and auditing, and feedback and improvement. Monitoring ensures that digital information management practices follow policies, standards, and regulations. Feedback from users and stakeholders is then used to improve systems and processes over time. In conclusion, the digital information management lifecycle helps ensure that digital information is created, managed, used, preserved, and disposed of in a systematic and responsible way. In this section, we will discuss the salient aspects of digital information management, based on key ideas from established researchers in the field. The first aspect is data acquisition and creation. According to Smith and Jones, 2021, this refers to the process of obtaining and generating digital data from various sources. Key activities include creating digital content and scanning printed documents into digital form. The second aspect is data organization and classification. As explained by Brown and colleagues in 2022, this involves structuring and categorizing digital information using metadata standards, tagging, and indexing to support easy retrieval. Next is data storage. According to Johnson, 2023, digital information must be safely stored in databases, cloud storage, or digital repositories, with strong security measures and backup mechanisms to prevent data loss. Another important aspect is data retrieval. Williams, 2020 highlights that efficient access to digital information depends on effective search engines and query tools that allow users to locate information quickly and accurately. The next aspect is data dissemination and sharing. As noted by Davis, 2021, digital information is shared through platforms such as email, social media, and collaborative systems, while ensuring compliance with copyright laws and organizational policies. Data preservation and archiving is also a critical aspect. According to Clark and Martinez, 2023, this focuses on maintaining digital information for long-term access and archiving outdated data using appropriate preservation techniques and archival systems. Another key aspect is data security. Harris, 2022 emphasizes the importance of protecting digital information from unauthorized access and cyber threats through encryption, access controls, and regular security audits. Next is data quality management. According to Lopez, 2023, this aspect ensures the accuracy, completeness, and reliability of digital information through validation processes and quality checks. Finally, compliance and legal considerations are essential in digital information management. As highlighted by Zhang and Li, 2024, organizations must comply with legal and regulatory requirements, including data protection laws and governance frameworks. In summary, these aspects, supported by established scholars, work together to ensure that digital information is well managed, secure, reliable, accessible, and legally compliant throughout its lifecycle. Digital information management is applied across many sectors. In this slide, we will look at real-world examples to understand how digital information management works in different contexts. First, in the education sector, universities use digital library systems. These systems provide students and lecturers access to e-books, academic journals, and research papers. Key activities include organizing resources using metadata, managing user access, and digitally preserving older materials. Next is the healthcare sector. Hospitals use electronic health records, or EHR systems, to store and retrieve patient medical histories. Digital information management here focuses on securing patient data, ensuring compliance with health regulations, and enabling fast and accurate data retrieval for medical staff. In the government sector, digital information management is used in e-government portals. These online platforms allow citizens to access public services and official records. Key activities include managing digital documents, implementing role-based access control, and ensuring data privacy. In the business sector, companies use customer relationship management, or CRM systems. These systems store and analyze customer interactions and sales data. Digital information management supports organizing customer information, analyzing trends, and automating customer service workflows. In media and publishing, organizations rely on digital content management systems, also known as CMS. For example, a news agency manages articles, images, and videos digitally. Activities include categorizing digital assets, managing publication workflows, and archiving older content. In libraries and archives, digital information management is seen in institutional repositories. Libraries use these systems to store and share theses, dissertations, and research outputs. Key activities include digitizing physical records, ensuring accessibility, and preserving scholarly content. In e-commerce, online retailers use product information management or PIM systems. These systems manage product descriptions, prices, and availability. Digital information management ensures standardized product information, real-time inventory updates, and support for multi-channel sales. In the cultural heritage sector, museums create digital museums. Artifacts are digitized and displayed online for public access. Activities include digitizing artifacts, creating interactive exhibits, and preserving cultural data. In banking and finance, organizations use digital records management systems. Banks manage customer account records and transaction histories digitally. Digital information management focuses on securing financial data, automating regulatory reporting, and ensuring disaster recovery. Finally, in scientific research, institutions develop data repositories. These repositories store large datasets from experiments for analysis and reuse. Key activities include storing datasets, implementing data sharing policies, and ensuring long-term preservation. In conclusion, digital information management plays a critical role across sectors by ensuring digital information is organized, secure, accessible, and preserved, regardless of the industry. Digital information management consists of several key areas that guide how information is handled from the beginning until the end of its life cycle. The first key area is collection. At this stage, we examine how information is collected by an organization. Information may be created internally or obtained externally. It can exist in many forms, such as electronic files, paper documents, verbal records, written text, audio, or video. It is very important to collect only the information that is necessary. This helps reduce storage costs, avoids analyzing unnecessary data, and ensures that the information collected is of good quality and useful for business governance. In today's digital environment, extracting information from digital documents is also crucial. One effective method is using high-quality optical character recognition, or OCR software, which converts scanned documents into searchable and usable digital text. The next key area is storage. At this stage, we decide where the collected information will be stored. Digital information can be stored in databases, document management systems, information systems, or cloud storage. It is also important to configure user access, manage version and change control, perform regular backups, and maintain audit trails to ensure information integrity and security. The third key area is distribution. This step involves deciding how information will be distributed, in what digital format, to whom, how often, and through which digital channels. Information is only valuable when it reaches the right person at the right time, so that appropriate action can be taken. This makes distribution a critical phase in ensuring the success of digital information management. Next is archiving. Archiving is the process of securely storing inactive digital information that is no longer used regularly but is still important. Such information may need to be retained for future reference, historical value, or regulatory compliance. At this stage, organizations must clearly define where information will be archived digitally and how long it must be retained. The final key area is destruction. According to various rules and regulations, such as those related to electronic records and digital documents, information should not be kept longer than necessary. Digital information that has outlived its usefulness must be securely destroyed. This step is critical because it helps organizations avoid fines and penalties for non-compliance and also reduces unnecessary storage costs. In conclusion, the key areas of digital information management, collection, storage, distribution, archiving, and destruction, ensure that information is handled efficiently, responsibly, and in compliance with legal and organizational requirements. To better understand how a digital information management, or DIM, program works in practice, let us look at a simple case study of an organization implementing DIM. Imagine a medium-sized organization, such as a university faculty, government department, or company, that manages a large amount of digital information. Step 1. Create a governance framework. The organization first creates a governance framework. It clearly defines roles and responsibilities. For example, department heads are identified as data owners, the IT unit manages the systems as data custodians, and management sets policies for access, protection, and distribution. This ensures everyone understands who is responsible for what when handling digital information. Step 2. Categorize information. Next, the organization categorizes its digital information. For example, student or customer records are classified as mission critical. Financial reports and operational documents are classified as important. Old reports and historical records are classified as legacy data. This categorization allows information to be managed based on its value and sensitivity, rather than treating all data the same. Step 3. Store digital information according to its value. Based on the categories, the organization decides where to store the information. Mission-critical data is stored on Tier 1 storage with fast access. Important data is stored on Tier 2 storage, which is secure but less costly. Legacy data is archived permanently off-site, while personal data that is no longer needed is securely deleted. This approach reduces storage costs and improves system performance. Step 4. Protect data according to its value. The organization then applies different protection strategies. Mission-critical data is replicated several times a day to prevent data loss. Important data is backed up daily to an alternative location. Legacy data remains safely archived off-site. This ensures data protection is proportional to the importance of the information. Step 5. Access management. Next, the organization implements access management controls. For example, administrators have full access. Staff may have read and write access. Students or general users may have read-only access. Some users may have no access at all. This prevents unauthorized access and improves accountability. Step 6. Digital information disaster recovery. Finally, the organization develops a digital information disaster recovery plan. It regularly tests data recovery and business continuity procedures to ensure systems can be restored quickly after cyber attacks, system failures, or natural disasters. This step ensures the organization can continue operations with minimal disruption. This case study shows how a digital information management program works in practice. By following the 6 steps: governance, categorization, storage, protection, access management, and disaster recovery, organizations can manage digital information securely, efficiently, and responsibly. In conclusion, this chapter has introduced the concepts and importance of digital information management in the digital age. We explored what digital information is, why it must be managed properly, and how digital information management supports security, accessibility, efficiency, and compliance. We also examined the digital information management lifecycle, key areas, and real-world examples across different sectors. In addition, we discussed how organizations can plan a digital information management program by following 6 key steps: creating a governance framework, categorizing information, storing and protecting data according to its value, managing access, and preparing for digital information disaster recovery. These concepts help us understand that digital information is a valuable asset that must be managed responsibly throughout its lifecycle. By applying good digital information management practices, individuals and organizations can ensure that digital information remains useful, secure, accessible, and reliable over time. That concludes this chapter on digital information management. Thank you for your attention, and I hope this session has helped you understand the importance of managing digital information effectively.